Today we look at the present value of an annuity. The present value refers to the single amount of money that, if invested at the same rate of interest as the annuity, would result in the same amount at the end of the same period of time. It's a great way to determine how much may need to be invested at the start of a period of time if you want to access regular payments every month for that period of time. Let's look at an example. An annuity involves depositing $2,500 at the end of each year for 5 years. Interest rate 6% per annum. We note that all time units are in years, so we won't have to convert any of that. We're first just going to find the future value of this annuity so that we need to know what the final result of the annuity will be. We find the interest factor from the future value table for 5 years at 6% per annum, and that's 5.6371. We substitute that into the formula. So the regular payment is $2,500 times the interest factor. Gives a future value of $14,092.75. We now want to find the single amount invested at the beginning of 5 years that will result in that same $14,092.75. To do that, we're going to use the compound interest formula. We know the amount at the end, which was the future value we've just calculated. We know the interest rate is 6% and the time period 5 years. And we want to find the principal amount at the beginning. To find the principal amount from this equation, we're going to divide by 1.06 to the power of 5 on both sides, which gives us a principal amount of $10,530.92, which is the present value of this annuity. Therefore, the two options will both have exact same value at the end of the 5-year period. Whether we invest $2,500 every year for 5 years at 6% or a single $10,530 at the beginning of the 5 years. You now have to attempt question 1. In your exercise books, please always write down the formula you're using. Show all steps of working so that we can know exactly how you got to your answer. As we've seen, in the previous method, once again, we had quite an amount of working out to do, which could be made quite a bit quicker if we use the present value tables. Just be careful now. When you're working with future value or present value tables, make sure that you are looking up your value in the correct table of what you're working with. For those of you who are interested, these values in the table are just the same formulas we've used before, and it's calculated from the formula we use to getting the future value and the formula for compound interest. It's just applying those formulas who gave us the values in this table. But for the work you have to do, the tables will be supplied to you and you don't have to know those formulas off by heart. Let's look at an example now using the present value table. Peter invests $300 at the end of every month for 5 months at 4% per month. All the time units are in months, so we don't have to convert anything. The present value formula is the regular payment times the interest factor from the present value table. From the present value table, if you look at the factor for 5 months at 4% per month, it's 4.4518. Substituting that into the formula, $300 per month times the interest factor gives a present value of $1,335.54. Now use the compound interest formula to calculate the final amount of this investment. So we want to know, to double check, if we invest the 1,335.54 for 5 years at 4%, will it give us the same total at the end of the time as the regular deposits will give? That's a total of $1,624.89. Let's double check using the future value interest factor table with the regular payments. 300, and if we find in the future value interest table the factor for 5 years at 4%, it's 5.4163, and it gives us the exact same future value of $1,624.89. You now have a few questions to do in your exercise books. Please pay attention to working out and that all steps are very clearly shown. Pause the video as you need time to complete these questions. And that concludes the work for this topic.